Example number 1, using arrow notation. Use arrow notation to describe the end behavior and local behavior of the function graph in figure 6. First thing we want to do is we want to identify what's on the graph. So if you take a look at this red line here, okay, that is our vertical asymptote. And it's passing through the x-axis at the value of 2. So therefore, x is equal to 2. That is the vertical asymptote. And then we also have a horizontal asymptote here. And that is passing through the y-axis at y equals 4. Okay, so those are two important things that you have to first identify on the graph. Okay, and so now what we want to do is we want to figure out, okay, what's happening with the end behavior and the local behavior. Now, the local behavior, okay, is what we're going to focus on first. So again, at the beginning of the sentence here, okay, we can notice that the graph is showing a vertical asymptote at x equals 2. And when you have a vertical asymptote, it's telling us that the function is undefined at that value, meaning at x equals 2. So the local behavior is the following. Okay, now let's take a look at the x-axis. Okay, as x is approaching 2. Okay, so you're looking at the x-axis. That means when you're looking at the graph in blue, okay, and I'm going towards the right towards 2, that means as x is approaching 2, coming from the left side, okay, what is the function doing in blue? It's going towards negative infinity. So that means f of x is approaching negative infinity. So we can see that is our local behavior for the first part of the graph. Okay, now we need to also check what's happening when you're approaching x at 2 from the right. So on the x-axis, if I'm going to 2 here on the x-axis, meaning as x is approaching 2 from the right, well, what's happening with this function up here? Well, this function is going towards positive infinity. So that is our local behavior. Now what we want to do is then we need to check out what is happening with the end behavior. Okay. Now with the end behavior, as the inputs decrease without bound, okay, and that means as x is getting closer and closer to negative infinity, or as it's approaching positive or negative infinity, what's happening at the horizontal asymptote? Well, you can see here that the inputs decrease without bound. The graph appears to be leveling off at the output values of 4, okay, indicating a horizontal asymptote at y equals 4. So the graph isn't going to cross that horizontal asymptote, okay? So as inputs increase or decrease without bound, they level off at 4. So let's take a look at that. So what's happening here is as x is approaching now negative infinity, our function here, this graph, is approaching the value of 4. But it's never going to touch it, but it's approaching the value of 4. It's not going to go anything further than that. So there is our end behavior. Okay. Now, if we take a look at the other side, now as x is approaching positive infinity, okay, so this graph is getting where? It's approaching 4 as well. So the function here is approaching the value of 4. So as x is getting larger, the function is getting closer and closer to the value of 4. So that's given us our end and local behavior. Okay, you want to make sure that you go back and review those slides where we talk about the local and end behavior if you need more information about this example.